Part 2 on time value of money, and now we're going to look at bond and lease payments and future value. Now again, we're focused primarily on the first three, which are present. When do you use the present value table? Well, present value table is always going to be if you have a single sum or if you have a number of single sum payments of irregular amounts. So that's when you'd also use this table. Now, if you have payments of the same amount over a period of time with the first payment at the end of the period, you can use your present value of an ordinary annuity. Or if you have the same payment over a period of time with the first payment due at the beginning, you use present value of an annuity due. Now we're going to take a look at some problems and show you how you would use these, when you would use which factor. All right, on September 30th, Mike Corporation issued 8% bonds with a face amount of $300 million. The bonds mature on September in 20 years. The market rate of interest for similar bonds was 10%. That's called the effective rate. Interest is paid semi-annually on March 31st and September 30th. First of all, you need the following in order to determine what is going to be the amount of cash that's received when this bond is issued. So, first, the face of the bond. We know that's $300 million. We need the stated rate because that's what you're going to use to determine the actual cash payments. The effective rate. That's what you're going to use when you look it up on the period tables. And the number of periods, this also you need to know because that's going to be used again when you look at your present value tables or future value tables. So remember, you always want to check when there are payments if they're semi-annually, because if they're semi-annually, that means you've got to take the number of years times 2. So now let's walk through this problem. All right, again, we're going to identify the things we need, which is the bonds payables face. It's a single payment of $300 million at the end of 20 years. And the number of periods is going to be 40 because it's semi-annual. The stated rate is we're going to receive 4% of the face of the bonds, the $300 million, every 6 months. Or we have to pay. In this case, pay. And then the semi-annual interest payments, use the stated rate, is going to be $12 million every 6 months. That's what they're going to have to pay. That's always the cash. And the effective rate, which is what we're going to use when we look up the factor on the table for the present value of those semi-annual interest payments, we're going to use the effective rate divided by 2 or 5%. Now we need to determine the present value of a single payment, which is our present value table, and 40 payments of $12 million. We need the present value of an annuity with an effective rate of 5%. We need to find the two factors, so we're going to look at both those tables. Remember, interest is always shown at an annual amount. If there are multiple payments during the year, then the interest rate used for the tables is the rate divided by the periods in the year times the number of years. All right, here's our table. This is for, we're first going to the present value table. It says present value of $1, and it's for the $300 million. It's a single sum due at the end of 40 periods or 20 years times 2. So we go here, and then we're going to go across to 5% to find our factor, and we get 1.14205. So we're going to take that times our $300 million to get the present value. Now we're going to go to the present value of an annuity for the $12 million that's going to be paid for 40 periods. So again, we're going to 40. And then we're going to find our factor, and we're going to take that times our $12 million. So here is how we determine how much cash we receive when we issue the bonds. First, we're going to take the $300 million times the present value factor, which is $42,615,000. And then we're going to take the semi-annual interest payments times the present value factor. So the total cash proceeds we're going to receive when we issue this $300 million bond is $248,524,080. Now our journal would look like this. The bonds payable is always the face of the bond. The cash is based on our calculation, and in this case, since we have to debit it and the proceeds are less than the face of the bond, we have a discount on bonds, which we're going to have to amortize every time we make an interest payment. First interest payment. Our cash is going to be the $12 million. Remember, that's always the face of the bond times the stated rate divided by 2 since it's semi-annual. Now, that's for the cash. Now, for the whenever you use the effective rate, the second calculation is always interest expense, and it's the net book value of the bond, which is the bonds payable minus the discount on bonds in this case, or the $248,524,080. That interest expense is going to change every single time you make a payment, because it's going to be, the discount on bonds is going to be reduced every time you make a payment. So in this case, we're going to reduce our discount on bonds by $426,204. That's the amount we're going to amortize. Now we're going to look at another example, and it has to do with a lease payment. On March 31st, Southwest Gas leased equipment from a supplier and agreed to pay $200,000 annually for 20 years, beginning at the end of the first year. General accepted accounting required that a liability recorded for the lease. The present value of the scheduled payments. Assume that a 6% interest rate properly affects the time value of money. What amount would be recorded? We know it's 20 years, number of years. Now, you notice they're not semi-annual, so it'd just be 20 years. The interest is 6%. The annual payments are $200,000. So now we're going to go to an ordinary annuity table. We're going to look at a factor for the present value of an annuity. We're going to go number of periods 20, 6%. So we go down to our 20. We go across to our 6%, and we get 11.4692. So now we can figure out what is our present value. So actual cash paid is $4 million over the period. The present value of the $200,000, or the amount that is going to be against what it's worth in today's dollars, and the interest expense over the 20 years, which will amortize over the 20 years, is $1,706,016. So let me show you the journal. It would be right of use asset, and it would be the present value of the payments. So we set up, whenever we have this lease, this type of lease, which is almost all of them now, is we're going to set up an asset and set up a liability. Now, what does it look like if instead the first payment is at the beginning of the lease? So if it's at the beginning, we're going to have to use the present value of an annuity due. We go down to 20 periods. We go across. We have a new factor. And now we can do our calculation. Now, if you notice, the present value is going to be $24.31. Interest expense over 20 years is going to be less because we've already made that first payment. So, our interest expense is lower than before, which was $1,706,000. Now it's only $1,568,000. And again, here's our journal. Right of use, lease payable. Now we're going to go through and look at some examples. What do you do? Mike wants to accumulate $100,000 to be used for his son's college education. He would like to have the amount available in 5 years. Assume that the funds will accumulate in a certificate deposit paying 8% interest compounded annually, required. If Mike were to deposit a single amount, how much would he have to invest at the beginning of the first year? If Mike were to make 5 equal deposits at the end of each year, what is the required amount of each deposit? And if Mike were to make 5 equal deposits at the beginning of each year, what is the required amount of each deposit? So, for the first one, what we need to do is we need to figure out how much we'd have to deposit today. So we're going to use our present value table, and we're going to get our factor, 5 years, and we get a factor of 0.68058. And based on this, if he put $68,058 in the bank today and he knew he could earn 8% interest at the end of 5 years, he'd have $100,000 in the bank. Now for the second one, we have to solve using the present value of annuity because the payment is at the end of each year for 5 periods. Now here's how we would do it. We would first get our factor. And then we're going to take 100,000 and we're going to divide by the factor because normally we multiply it. Now we're going to divide by it, and that tells us what we would have to do is put $25,046 at the end of each year so that we would have $100,000 at the end of 5 years. Now let's look at the last one. In this case, we want to make a payment up front, so we're going to use the present value of an annuity due. We're going to go to our table, get our factor, and now we're going to divide by that factor, and if we make the payment at the beginning of each year, all we would have to put in the bank is $23,190. So what should Mike's decision be? Well, it depends on how much cash he has. If he has $68,058 right now, he should put it in the bank. But if he doesn't, then the other ones, either one, get the same result. Depends on how quickly he can get his cash. And that ends this presentation.